Welcome back to the Foundation in C# course. We are currently in Module 6, and this lesson we're going to be covering inheritance. So we're going to figure out what inheritance is, how it works, and why we should use it. Okay, so let's start off with Visual Studio. And here I have the new project, or the start menu. We're going to go to a new project here. And in here, we're going to create a console application. That's what we've done so far. We're going to not do a console.NET Core, even though that's kind of the newer way of doing things. We're not going to here because of the fact that we've done .NET Framework. We are going to transition to .NET Core. But for right now, there's not a need to, because the code we write here will work the same no matter where we use it, whether it's .NET Core, .NET Framework, or even mobile applications. So what we're going to look for is a console application, but with the .NET Framework. Okay, so see the .NET Framework in parentheses? That's the one we'll use. We'll hit Next. And we'll call this Inheritance Demo. And the solution name will be Inheritance Demo App. Now for this, I'm using the .NET Framework 4.7.2. And it's fine if you're using a little earlier, 4.7.1 is fine, even 4.7, but I wouldn't, if you can, go to the full .NET 4.7.2. So you can get those, you can download the latest version in case your Visual Studio doesn't have it. You can download the latest version from Microsoft for free. That's just something included with your Visual Studio. So normally it just comes with a version and it upgrades, but sometimes you have to actually download it and update it. So just make sure it's 4.7.2 if at all possible. That gives you the latest and greatest stuff. Okay, once I hit Next, here we have our console application. So the first thing we'll do is we will add our console read line at the end, like so. And now we're ready to start talking about inheritance. So let's talk through what is inheritance, and we can figure out when to use it and why to use it. So inheritance is the idea that we can put code into a class and say, there's another class that's kind of like it. It's kind of a child of it. And it wants to use as a lot of that or all of that functionality in the child class. We don't want to duplicate our work. That's kind of theoretical. So let's talk specifics. And I'll give you a couple of pretty standard examples, and I'll talk through our actual example we'll be using in this lesson. So I'm going to do a class right in here in the program.cs. We'll move it out of the program.cs, but it's nice to see it in one place. So a standard demo for inheritance would be to say public class car. And you know what's common with cars? Well, we could have number of wheels, because cars usually have 4, but they could have more or less. We could have number of doors. We could have a public void start car method that starts the car. We could have, another one that's public void stop car as well. And of course, we're not filling any of these in. We're just kind of defining the base of a class where we have a couple of properties. We have a couple of methods. Now, if we have multiple types of cars, let's say we had a Corolla. So I grew up, I had a Toyota Corolla. So Corolla is a type of car. Well, if I had to say number of wheels, and then so on and so forth, number of doors, start car, stop car, and have all those, we're repeating ourselves, right? We're doing the same exact thing because a Corolla is a car. And so what we can do instead is And let's just look real quick before we do. I want to show you this. If I come up here in the main and I say car, let's call it car equals new car. I can say car dot and get number of doors, number of wheels, start car and stop car. But if I did, instead of car, if I said Corolla equals new Corolla, and I said Corolla, I only get the 4 that come with, out of the box, come with a class. Those 4 methods. Methods. So I could recreate all of this and all this code. But if a Corolla has all the same stuff and it just works that way, what I can do instead is inherit. Where I say after the Corolla, I can put colon, car. And what that's doing is saying a Corolla is a car. So what's going to happen is Corolla will now have a stop car, a start car, a number of doors, and number of wheels, because it's brought those in from car, also known as inherited that from car. So car is now the parent of Corolla. So now if I come up here and I say Corolla dot, I've got number of doors, number of wheels, start car, and stop car, which is kind of cool. So we have the ability now to bring in code from a class and use it in a child class. It gets even more powerful when we think about the idea that there's more than one type of car. Let's just say public class Camry. That's also type car. Well, now Camry also has these 2 properties and these 2 methods. And that sounds great. And we've got this idea that we can essentially, and this is where it kind of breaks down a little bit. It feels like we're sharing code. And it feels like, man, this is really powerful. So I can write one class and share that code throughout other classes. And that's not the right approach. And so I've been very clear about how I say this, but let's actually put it into a comment. A Corolla is a car. A Camry is a car. And the reason I'm being very careful in how I say that is because these 2 words right here help you figure out if inheritance should be done. They're not the total test, but it's a really good start. Okay? Because if I had another class, let's do public class Tundra. Should I say car? Well, no, because a Tundra is a truck. And a truck is not a car. And you may say, yes, but the Tundra has the stop and the start and stop. It has number of wheels, number of doors. It has all those things. Well, first of all, start car. Well, yeah, but Tundras start too. So we can just ignore the fact that it says car and know that it really means start. Or we can even come back here and modify these and say start and stop. But this doesn't pass the test because a truck is not a car. And this is what trips people up is, yes, they say it's not a car, but I want all those things. And that's not a good reason to have inheritance. Just because you want something from something else and you want to share it doesn't mean that inheritance is the right way of going. Okay? So this is our basic example. What we're going to do is I'm going to move these over into files so you have them, but this is not the example I want to go over because I've got an example that I think will help illustrate this a bit more, and it will help us see the differences between when we should inherit and when we should not. Okay, so what I'm going to do is I'm going to put my cursor on car and do Control Dot, which allows me to move this to its own file, cars.cs. Notice it's over here now. I'm going to do that for all of these classes. And this is what you should be doing whenever you create a class, is you should move it to its own file. But it's okay to put it in a file where you're working to kind of see it, and then you can move it once you're done. Just make sure you always move it, because a class should be in its own file. You shouldn't have more than one class in a file. Okay, so now we've kind of cleaned things up. We can get rid of these two sample lines. They were just to show you that those properties and methods added on. So let's create a class. We'll do it in here again. Public class phone. And a phone has a couple of things it can do. So we're going to have a public void place call. And then we'll have a public void end call. And let's leave it there for now. These are just sample classes. We're not actually filling in methods here and writing that. We're just kind of showing off inheritance, not all of building entire classes. Okay, that's kind of the difference. And this is, for testing purposes, this is exactly how you should be doing it, because this allows you to test it very quickly without getting bogged down in unnecessary details. So we got this phone class because there's many different types of phones. But all phones, and this is kind of key, all phones place calls and end calls. That's kind of the definition of a phone, is it can make a phone call and it can hang up that phone call. Now, some phones can do more than that. But when you're talking about inheritance, you have to put only the things that everything below it will do into that class. And you'll see why in just a minute. But let's create a new class, public class cell phone. And we'll inherit from phone. So now cell phone has place call and end call, but it also has, let's create a list of string just to kind of represent, and have apps. Because cell phones usually have apps. And I say usually, and that's going to kind of bite me, because what if it's a cell phone that's a flip phone? Well, flip phones actually have a couple of apps on them normally. But maybe there's a chance where it doesn't. And then that's the case where, well, that shouldn't be here then. That should be one level deeper. Maybe it's a smartphone. And I think that's probably a better way of going about it. So we're going to move that to a new class. Let's call it public. Man, I can't spell public today. Public class smartphone. And the definition of a smartphone is that it has apps, that it does other things besides just make calls. So let's move this over here. Now, is a smartphone a phone? Well, yes, it is. So it can inherit from phone. But is a smartphone a cell phone? Well, yeah, a smartphone is a cell phone. Therefore, we should say cell phone. Because now we're inheriting from cell phone, and cell phone inherits from phone. So phone is technically a grandparent relationship to smartphone. But yet smartphone will get all the stuff from phone and all the stuff from cell phone. We'll see that in just a minute. So what does a cell phone have that a phone does not? Well, it has a carrier. And that's the company that actually provides the mobile service. Okay, so in the US, we have Verizon, AT&T, and a few others like T-Mobile and Sprint. So that would be the carrier. Okay, and smartphones have carriers because they are cell phones. So now if we look at smartphone here and said smartphone dot, we have our apps. We also have carrier, plus we have end call and place call. So we have stuff from the phone, plus we have stuff from the cell phone, plus we have stuff that's ours as well. So that's how inheritance works, is it allows us to inherit from a parent who can themselves can inherit from something else. And so we actually pass things way down the chain. Now, one thing to note, and this is very, very, very important. You cannot inherit from more than one parent. So I couldn't have said cell phone and phone here. It wouldn't have made sense anyways, but let's just say I couldn't do that. That's not possible. You can only have one parent that you inherit from. Now, as you can see, yes, smartphone only has one parent, that's cell phone. But since cell phone has a parent, a phone, it actually gets the benefit of that double inheritance. But the reason why that's okay and possible is because we're following the is a relationship. And so if a smartphone is a cell phone, and it is, and if a cell phone is a phone, and it is, then it stands to reason that smartphone is a phone. You see that? That progression holds true because everything follows the is a relationship. If you find that your grandparent-grandchild relationship doesn't fit the is a relationship, you've broken inheritance. So there's something wrong there somewhere. All right, so we have this phone class, and I'll collapse this down. We have a cell phone class. We have a smartphone class. Let's add one more class, because why not, right? Public class landline. So a landline is a phone that actually connects to the wall. It's corded into the wall and it goes over the actual physical telephone lines. So what does that inherit from? Well, it's not a cell phone because cell phones use cell towers, there's no wires. Smartphones, of course, not a landline because a smartphone is a cell phone. But a landline is a phone. Therefore, I can say phone. And now, if I come up here and say landline equals new landline, landline dot, a landline can place calls and end calls. And that's correct. That's pretty much all a landline can do. But now we have the ability to inherit from the right place. Okay, so we're inheriting from phone. But do you see why it's important where we placed this carrier? inheriting from phone. Therefore, a landline must be able to place a call and end a call. There are ways of getting around this, and they're not smart. I've seen people advocating for turning off certain features you don't use, but still inheriting from that. And that's a really dangerous situation. Okay. You do not want to start turning off. Let's just say landlines couldn't end calls. You don't want to turn that off, because then if someone says, oh, you have an end call method, I'm going to call that, it's going to crash their application. So don't do that. Okay. So now I'm going to add in the smartphone, I'm going to add another feature. Public void connect to internet. Because a smartphone can connect to the internet. Now let's add a new class. And let's call it hotspot. Now, if you're not familiar with what a hotspot is, it's a little device that talks to the cell towers, and it allows you to connect to the internet through that device. So it's your own personal, kind of like Wi-Fi, but the thing supporting it isn't a physical line into the internet. Instead, it talks to the cell towers to get the internet. So that's a hotspot. So a hotspot can connect to the internet. A hotspot has a carrier. So I could say that a hotspot inherits from smartphone. But here's the problem. A hotspot does not have apps. And I say, okay, well, we can still inherit from okay, you're looking to hit that thing because you got the hammer, therefore it must need pounding in. But that's not the right choice most of the time. So inheritance has definite purposes. It's definitely valuable, but that doesn't mean you should use it to share code. That's not the purpose of it, not at least directly. Instead, it's to allow you to extend something. So for example, a phone has these two methods. Well, a cell phone has those two, but also has this. And so it's extending the purpose of a phone or the abilities of a phone. A smartphone extends a cell phone. It adds new abilities to an existing thing. A landline extends, or maybe not even, but it at least has the properties of a phone. Now, I would want to have something in there besides just being blank in order to have that class called landline, but that's still a possibility, okay? So these are all extensions basically off of the base class of phone. So when you get faced with a situation where you are coming across something that makes sense from a code sharing perspective, but not from a functionality perspective, meaning, here's an example. if we create a class and it's the weirdest name, but walkie-talkie. So a walkie-talkie is those radios you push the button and talk to somebody and then let go of the button. The other person pushes their button and talks back to you. And it's a, one way at a time communication. Well, those can place calls and end calls. It is not a phone. Therefore, you do not inherit from phone. A walkie-talkie is not a phone. Therefore, even though you want these two methods, don't take them this way. If you have to, make a copy. And that sounds weird coming from the guy that keeps stressing dry. Don't repeat yourself. But it's important because these are two different things. Even if the method behaves the same, they're two different things. Now, if you do have a method that behaves the same, what you can do is break that method out into a helper class and then call it from phone and call it from walkie-talkie. Now you're not repeating yourself, but you're not violating inheritance. And that's a big deal. Okay? So think that through when you are creating these inheritance structures. Does it follow the is a relationship, which that's over here? Does it follow the is a relationship? If it doesn't, it's not inheritance. It shouldn't be inherited. Okay, so that's the theory of it. That's a little bit of practice showing you how to do it. But one more thing to note before we move on, and that is about how you create these variables. So let's wipe these out and start over. I'm going to do something a little weird. I'm going to say phone. Let's say phone equals new smartphone. Guess what? That worked. And if I say phone dot, I have end call and place call. But that phone's actually a smartphone. I create a smartphone. A smartphone has the ability to have apps connect to the internet. I don't see any of those things here. Did I just make a mistake when I said new smartphone instead of new phone? No, I didn't make a mistake. And this is part of how inheritance works, is that a child class should always be able to fill in for the parent class. Okay, so if I say that this variable is a phone, I should be able to put in here anything that's either a phone or inherits from phone. And why is that? Because all I'm going to give you access to when I say phone dot is the stuff that phone has. End call and place call. That's all it has access to. That's all I'm going to give you access to because that's what you're using as a phone. But it can technically be behind the scenes a smartphone. Well, how is this useful? Imagine for a minute I had a list of phone. I could say phones.add new cell phone and create a cell phone. I could say phones.add new smartphone and add to the list. Okay, so I could add all these different types and store it in the same list. And if the reason why we do that is we want to make phone calls with these phones, and it doesn't matter what type of phone it is, then we're all set. We can make phone calls with cell phones, smartphones, landline phones, the base phone class, doesn't matter. And since we're following the is a relationship, we wouldn't be then making phone calls with hotspots because that's not possible. So if we'd called hotspot a phone, then when I came here, I could say phones.add new hotspot, which is like, well, what's that hurt? Well, if I do a for each phone in phones, and I say phone.place call, that's going to work great right up until the time it hits this hotspot. And then it's going to crash. And I'm saying, wait, but they're phones. I should be able to make a phone call with a phone. Well, we have a hotspot in there. It's not really a phone, and that's your problem. Okay? So don't do this. That's why it's important. Okay? So that's one of the reasons why you might want to have the phones listed, but yet store something else besides just phones in that list and kind of use that inheritance to your benefit. The other thing is, and I said, well, but if that phone is a cell phone, then put the value into a new variable called cell. And now you can use that like a cell phone. Okay? We can assign a value to it. I can do another if statement. If phone is smartphone, let's call it smartphone. I can say smartphone dot, and now I have access to apps, and I have access to connect to the internet. So I can say, you know what? Let's go ahead and connect to the internet. Now I can start using these again as if they're the full item, even though I'm storing them as a type phone. So even though you're storing it with the smaller type, the type that has less stuff in it, that doesn't mean you're limited to only using that type. In general, that's what you'll be using, but you can do this check, the is check, and if you find it's a match, then you can put it into a new variable. Now, there is a performance penalty for this because it's actually going to do this conversion check. So just note, it's not huge. It's tiny, but it is there. So it's not the same as just calling phone dot something. This does do a check, and that's a little more work than just saying, hey, phone dot. Okay? So just note that if you find yourself using this all the time in an application, maybe you want to think about a different way of going about how you build your application. But for most cases where you're not abusing it, this is a great solution and it's very performant. Okay? So that's how you can get around storing it as one type when it's actually a different type and you need access to that other type. All right, so let's go ahead and move all of these over into their own files. So again, just that control dot. When I'm selecting the class name, I can move it to move type to its own file. And then I have a lot more classes. This is where folders would really be helpful. We can start putting in folders and organize them by the different things we're doing. But I just created one big list for now. So with that kind of wraps up what we're talking about when it comes to inheritance. We figured out when to inherit and what that relationship is. That is a relationship that has to be in place. We figured out how to do parent-child, grandchild relationships and the benefits of that. We've also figured out how to have things that maybe sound right, but the reality is they should not inherit. And then finally, we kind of went over how to use the base class types for storing even the child class and the grandchild classes in that type. And then we went over, finally, I guess, one more thing. We covered how to bring it back the other direction using the is relationship or the is check to make sure that we brought it back into a new variable to be used if it is that type. Okay. Now, just quick note that if the second one here is smartphone, that is a cell phone. Therefore, it would hit this. Because, this isn't about creating methods that actually work. This is about making sure you understand how that inheritance works. Okay. So a vehicle class, a car class, a boat class, and a motorcycle class. And figure out, maybe there's something that all applies to all of those things. And if so, put it in the base class. But maybe it's that 3 out of 4 work, but 1 doesn't, or something like that. So just kind of think that through and get that homework done. Once you do, come on back for the next lesson.